Hello, in this tutorial we will see various 3D meshing options. Let's start with the making of hollow solid cylinder. First of all, plot the nodes of the center. Go to the geometry page and select solids and select this cylinder option. Select the bottom circle and select the normal vector. Enter the base radius as you desired, for example 10, and height as 100, and click on the create. This is a solid cylinder. Similarly, create a cylinder with 5 radius and same height. Now go to the solid edit and use the boolean operation type simple combine all and operation a minus b. We have to reduce a smaller cylinder from the larger one. Select a as this and b as this and go to calculate. Now we can see it created the hole in the larger one cylinder which is required. Now for creating the tetra and penta element, pyramid element, go to the 2D page, select auto mesh and mesh all the surfaces. Now go to the 3D page and select tetra mesh option. Use for the tetra mesh radio button, select component as this, select simple pyramid and select mesh. It is showing 65 nodes and 592 elements are created. We can see them. They may look like hex element, but they are tria and pyramids. Like this. We can also use volume tetra option, which doesn't require any 2D meshing before. It automatically meshes the elements into tetras. Into tetras. We use tetra element for an non-uniform type geometry. Otherwise we prefer hex elements. There are various tools to create the hex element like drag, spin, line and element offset, solid map, linear solid. Let's try solid map option. Go to the 2D page and mesh only this surface. After meshing this, go to the 3D page and select solid map. Go to the general button and select element to drag as all these elements. Destination geometry as this surface and along geometry as other surfaces. And click on the mesh. All these are the hex element. We can see them by masking. This is a hex element. Similarly, we can drag the element by creating the mesh first. Go to the 3D page and select drag elements, select this all element. Put the input distance as 100 because we have to drag up to the 100 units. Select the direction as Z direction. On drag it is asking how many elements you have to make, and after dragging put the value as 10. Select drag positive. It drags the elements. See what would happen if we put a value after dragging as 5. It dragged only 5 elements in 100 mm distance. We can also control biasing density. Let us try spin option. It spin the element along the center. For making 2D surface to the element, we required a surface let's carry it out mesh in the surface and spin it. Go to the 3D and select spin option, spin elements. As all axis as z axis and base as this. Angle 360 degrees on spin 6 elements and spin it. We had created the similar element by spinning. Other options are line drag, where we use line as part to drag. It is similar to the sweep option which is used in various CAD softwares. Let's consider the following problem. We will try to solve this following problem in different element types. We had created the 4 solids with elements whose size is 10. This one is tetra, this one is pyramid, this one is hex, and this one is penta. Now we will compare the result by all these 4s. We have to apply 100 Newton load. These are the 3 cylinders we have selected. Thus total 300 Newton load have to applied on this 12 into 3 nodes. Thus on each node we have to apply 8.33 Newton load. Set direction. For this cylinder we have to apply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only on 10 nodes. 10 Newton in each node. Now create the load steps. And run the analysis. It is showing the error missing properties for 2D element. The 2D element created should be deleted before the analysis. We can delete the 2D element by go to the config panel and select quad 4. and select. Let's check any other type of 2D element are not present here. Try 3. Okay, now run the analysis completed. Let's see the hyperview results. We can easily see the result are identical here. There is no very much difference in the result. Of course, data element deviate more from analytical answer. Also, the maximum value of displacement is shown in the hex element cylinder. We can also see the individual results by this button. It is requesting the node. Select the node and click on the apply. All these are the value of displacement showing in the particular nodes. We can easily see displacement in each node and easily conclude that N7 node shows the most accurate result. N7 is located in the hex type cylinder, whereas N446 shows the least accurate result, which is located in the tetra type cylinder. Also, the element created by hex element are the least as compared to other types of elements. Thus, it also required a least solving time.